Okay, this is day two again, but I managed to do another question. So I'm looking at two types of approaches to breadth search and depth search. So we will start off by going over the nums. So this is the typical flood field number of island question, where you have a 2D grid of 0 and 1s. So 0 indicates water, or in some sense later we'll see that 0 actually is equals to uh, a non-island or visited cell. So in this case, we only have one island because you see that you can go here or around. So even though it's a weird shape, right? These are all connected up, down, left, right. So they are effectively one island. Then we can use two approaches for this. So yeah, so take note only horizontal and vertical. The first approach is breadth search. So we use the same queue approach as your level order traversal, where each island itself is equals to one level. So you don't increment until you're done with this level. So you loop every cell in row order. So like this, like this, like this, like this. Okay, then if you find an island cell, what you want to do, the pseudocode is you want to increment the count by one, and then you do BFS on the island. So this BFS effectively spreads out 1, 2, 3, 4, and it will repeatedly try and change all the visitor cells to 0. So after, let's say for this grid, right, maybe we'll use the example 2. If I were to run BFS on this, what happens after the first iteration is that 1, 2, 3, and 4 will all become zeros. And then second iteration, this island will become zeros, the island, and then fourth island. So what we do is we find the first island cell. It can be any cell of one island because breadth search will spread out and cover the entire island. It's like how a virus spreads from patient 0. So we push this island cell into the queue, and then we mark it as 0, that visited or as no island, so that later we don't take into account this island again. There'll be repeated computations. Then we explore up, down, left, and right. And if let's say we find other land, we will continue to keep processing by putting into the queue, similar to how each island is equivalent to a level order traversal. That is one level. So what this does is we'll keep spreading out until we find that we are surrounded by water on the boundaries, and all of those island cells will become 0. So once one island is processed, we'll add to the count, and then we'll continue. So the code looks something like this. We get a row length, column length, islands. So we'll create a queue, and then we'll push the first coordinates there, the first island. So assuming BFS is only run on when you find an island cell, right? We will set it to 0. So while the queue is not empty, I'll pop out to get a row of the coordinates, and then I will check up. So if row is more than 0, I will check so if row is more than 0 means the second row onwards, I will check the cell on top of it. If it's 1, I will just push it so that I can process this as part of the same island, and then I'll set it to 0. Similarly for left, you must check if the condition of column is more than 0, then you can do a -1. Then for down, is to check that you're not below the boundary, so row length -1 and column length -1. So the -1 is very important because there is a zero-based indexing, and you want to go 1 before that. Right. So we run a for loop, OMN space time. So while this BFS has a queue inside, right, it will ensure that only cells that are island cells will be visited, which means that after you run BFS, right? Hello? Hello. After you run BFS on the grid, you will be ensured that those existing islands that you are processing now will not be visited again. That means you will visit the next island, which is on a cell that you've never visited before. And this means that each cell is only access a maximum of 1 time. Yeah, because if it's not a cell, you won't even go and process it. So once you process it, you increment the island, because this BFS call will ensure that all the land related to this island is set to 0 and visited, and then you can safely increase the islands. Okay, so now for the DFS approach. So using that first urge is the idea is the same, except now there's no queue. You don't have to do a queue. You can just go directly into one direction and try and solve it in that one direction. So what I mean is, effectively, you loop the cell in row order again. And once you find an island cell, you start DFS instead of BFS. So instead of just running all four directions, you will run up, down, left, and right to mark all those cells as visited, and then you increment the island. Yeah, not increment the island. So once you return everything, because the base condition is when it's no longer an island, so it's a boundary or if it's a boundary or if it's a water, then you will not need to continue going that direction. So DFS is actually usually done with a recursive call. So we will write DFS the row and column, and then we will check if the cell is visited. So if the cell is visited or not an island, right, we don't do anything. But if it's not, we will set it to 0. And then we will, same thing, we do up, down, left, right. So we go in the up position first. So if R more than 0, R minus 1, C. Then once this, on all the cells on top have been processed, right, we can go in the left direction, then down, and then right. Yes. So same idea. You run DFS until all the cells related to this island are done, and then you do island plus plus, and the time complexity should be the same.